You know that feeling in a newer car when you drift a little and the wheel nudges you back in line? Or when the car brakes for you, maybe even before you saw the danger? It can feel a little bit like magic, but it's not. It's an amazing suite of technologies all working together. So today, we're going to pull back the curtain on your car's digital co-pilot and figure out how this whole thing actually works.
So, where does all this technology come from? Well, it starts with a pretty simple and, let's be honest, kind of humbling fact. The data doesn't lie. The overwhelming majority of car crashes happen because of us, the drivers. One little moment of distraction, looking at your phone, being tired, that's the problem these smart safety systems are really trying to solve.
So, this led engineers to ask a really big question. What if your car could be more than just a machine? What if it could be a partner, a co-pilot that never gets tired, never checks its phone, and has senses that are, well, superhuman? That's the whole idea behind the tech we're going to break down today. Here's how we're going to do it. First, we'll define what this digital co-pilot really is. Then, we'll get into how your car actually senses the world around it and what its digital brain does with all that info. After that, we'll look at the features themselves, from simple warnings to the car taking action. And finally, we'll do a little reality check with the data to see how well these systems actually work in the real world.
All right, let's dive right in. What are we actually talking about when we say digital co-pilot?
So this isn't just one single gadget. It's a whole collection of technologies with a fancy name, Advanced Driver Assistance Systems, or ADAS for short. The basic idea is pretty straightforward. Use things like sensors and cameras to spot trouble, like a car slamming on its brakes or you drifting out of your lane. And then, this is the key part, respond. And that response can be anything from a simple warning beep to the car actually hitting the brakes for you. Okay, so if the car is going to respond, it has to know what's going on, right? It needs to be able to perceive the world. So let's talk about the eyes and ears that your car uses to do just that. What's so cool about this is that no single sensor is perfect, so your car uses a whole team of them, like a superhero squad. You've got cameras, which are great at figuring out what something is. You've got radar, the all-weather pro for judging distance and speed. LiDAR is the master architect building super detailed 3D maps. And then you have ultrasonic sensors, the experts in tight spaces, like when you're parking. Each one has a weakness, but together they cover for each other.
Let's start with cameras. These are pretty much what they sound like, the car's eyes. They're amazing at identifying things, telling the difference between a person, a bike, or a stop sign. But, and this is a big but, just like our own eyes, they really struggle when the weather gets nasty or it gets dark.
And that's exactly where radar steps in. This is the team's all-weather specialist. It uses radio waves that can see right through rain, fog, and darkness to tell you how far away something is and how fast it's moving. It's the absolute MVP for features like adaptive cruise control. Its only problem, it's basically colorblind and can't read signs. Now for the really cool one, LiDAR. This thing sends out thousands of little laser pulses every second to build an incredibly precise 3D map of everything around the car. It's amazing for understanding really complex situations. The downside has always been that it's more expensive, and like cameras, it can sometimes get tripped up by bad weather. And finally, we've got the unsung hero, the ultrasonic sensor. You know that beep 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 sound your car makes when you're backing into a parking spot? Yup, that's these guys. They use sound waves, kind of like a bat, to detect things that are super close. They don't have a lot of range, but for parking, they're perfect. Okay, so the car has its senses, and it's collecting tons of information. Now what? Well, it needs a brain to process all that data, and that brain has been evolving like crazy over the past few decades. If you look at cars from the 90s, they were a total mess of electronics. Dozens of little separate computers called ECUs, all connected by a giant spider web of wires. Then things got a bit more organized with domain controllers, which grouped similar functions together. And now, the big push is toward one single, super powerful central computer that runs the whole show. So why does any of this matter to you? Well, switching from that scattered mess to a centralized brain means way less wiring, which makes cars lighter and cheaper to build. But the real game changer is this. It allows for over-the-air software updates. Just like your smartphone, your car can actually get new features and improve over time. That's huge. And this is where the brain performs its coolest trick. It's called sensor fusion. This is the process of taking all the information from the different senses, the camera, the radar, the LiDAR, and blending it all together. Maybe the radar spots something in the fog, and a second later the camera confirms, yep, that's a car.
By fusing all this data, the brain creates one single, highly accurate picture of the world that's way more reliable than what any one sensor could see on its own.
So we have the senses and we have the brain. Now let's talk about the fun stuff. How this all turns into the features you actually use and experience while you're driving. This is where the car goes from just watching to warning, and sometimes even acting.
The first group of features are basically just giving you a heads up. It's your forward collision warning beeping at you, or the steering wheel vibrating a bit when you drift out of your lane, or that little light that flashes in your side mirror. Think of these as your digital co-pilot gently tapping you on the shoulder and saying, "Hey, you might want to look at this." But then you have the next level. These are the features that don't just warn you, they actually do something. We're talking about automatic emergency braking, which can slam on the brakes to prevent a crash, or adaptive cruise control that handles your speed in traffic. This is where the car briefly steps in and says, "Don't worry, I've got this." It's actively sharing the task of driving.
Now, all this technology sounds amazing, right? Almost too good to be true. So for this last section, let's do a reality check. How well does all this stuff actually perform out on the road, in the real world? And the news, for the most part, is really, really good. A study from the Insurance Institute for Highway Safety, or IIHS, found that automatic braking systems that can detect pedestrians reduce those types of crashes by up to 27%. Let that sink in. That's a huge life-saving difference. However, it's not a perfect story, not even close. When the IIHS tested a bunch of these partial automation systems in 2024, the results were pretty shocking. Out of 14 systems from different brands, none of them earned a good rating, and almost all of them were rated poor. This just goes to show you that there is a massive difference in quality from one car to the next. And a big part of the issue is that there's no standardization. One car maker calls their system Autopilot, another calls it ProPilot Assist, another calls it Blue Cruise. They all have different names, and they all work a little differently. That confusion can make it really hard for drivers to know what their car can, and more importantly, what it can't do. And even the best systems still have blind spots. That same study that found that awesome 27% reduction, it also found that these systems really struggle in certain situations, in the dark, on unlit roads, at highway speeds, or when the car is in the middle of a turn. These are the critical edge cases where the technology still has a long way to go. So where does that leave us? There is absolutely no doubt that our cars are becoming smarter and more capable co-pilots every single year, and that's making our roads safer. But as the technology gets more and more advanced, it raises a really important question for all of us. Our cars are getting smarter. Are we, the drivers, ready for what's coming next?